Hello, tech enthusiasts. Welcome back to our educational series. Today, we are delving into the fascinating world of computer organization. Understanding how computers are structured and organized is crucial for anyone interested in the field of technology. So, let's jump right in. John von Neumann, a brilliant mathematician and physicist, played a pivotal role in shaping computer architecture. His contributions were groundbreaking for several reasons. 1. Von Neumann architecture. He introduced what is known as von Neumann architecture, a concept that became the standard blueprint for computer design. This architecture is characterized by the use of a single memory unit to store both data and program instructions. 2. Sequential execution. Von Neumann architecture also brought the idea of sequential execution, where instructions are processed one after the other. This sequential flow is fundamental to how computers operate today. 3. Fetch decode execute cycle. The famous fetch decode execute cycle, a crucial aspect of computer operations, was a result of von Neumann's work. This cycle represents the process of fetching instructions, decoding them, and executing the operations. In essence, John von Neumann's insights in 1970 laid the groundwork for the logical structure and functioning of computers that we still follow today. Computer architecture deals with the functional behavior of a computer system as viewed by a programmer. It can also be described as the logical structure of the system unit that housed electronic components. The first computer architecture was introduced in 1970 by John von Neumann. Now the basics as we explore the fundamental components that make up a computer. It's like getting to know the essential building blocks of the digital world. So, let's dive in. 1. Input unit. Imagine this as the gateway for your computer. The input unit is where information enters the system. It's like the keyboard you use to type, the mouse you navigate with, or any other device that feeds data into your computer. So, every time you type a message, click a link or swipe on your touchpad, you're engaging with the input unit. It's like the computer's way of asking, "What do you want me to do?" 2. Output unit. Now, let's talk about the results, what your computer gives back to you. That's where the output unit comes in. It includes your screen, speakers, or any device that presents the information processed by the computer in a user-friendly way. When you see a document on your screen, hear a song playing, or even print a paper, you're witnessing the magic of the output unit. It's the computer saying, "Here's what I've done for you." 3. Central processing unit, CPU. Now, let's get to the brain of the operation, the CPU. This is the powerhouse that processes all the data. Think of it as a decision maker, the one doing the heavy lifting of calculations and executing instructions. So, whether you're running complex software, playing games, or even just browsing the web, it's the CPU that's working behind the scenes to make it happen. It's like the conductor orchestrating the entire performance. 4. Memory unit. Last but not least, let's talk about memory. No, not the kind where you store photos on your phone, but the digital memory inside your computer. It's like the short-term and long-term memory of your system, allowing it to store and retrieve information. So, when you open a program, the memory unit makes sure it's readily available for the CPU to use. It's the computer's way of saying, "I remember this, and I'll use it when needed." Understanding the input unit is like the gateway for your computer. It's the doorway through which coded information enters the system, allowing us to give instructions and provide data to our digital companions. Examples of input devices include the keyboard, mouse, and more. So, every time you type on your keyboard, click your mouse, or interact with any input device, you're essentially communicating with the computer through the input unit. It's our way of saying, "Hey computer, here's what I want you to do." Slide. *** functions of the input unit. *** Now, let's explore the functions that the input unit performs to make our communication seamless. 1. *** Accepting instructions and data. ***. The input unit serves as the listener. It patiently accepts the instructions and data we provide. Whether it's typing a document or clicking on an icon, the input unit is ready to receive. 2. Conversion to computer-acceptable format. Once it receives our input, the input unit acts as a translator. It converts our human-readable instructions and data into a format that the computer understands. It's like translating our language into the language of the machine. 3. Supplying converted information to the computer. After the translation, the input unit hands over the converted information to the computer system. It's the delivery person ensuring that our instructions and data are passed on for further processing by the computer. So, in essence, the input unit is not just a messenger, it's the translator and mediator between us and the computer. The output unit is the messenger that delivers the results of our computer's hard work. It's the storyteller, displaying the outcomes of our digital endeavors in a form we can comprehend. Examples of output devices include monitors, printers, and plotters. Functions of the output unit. Now, let's delve into the functions that make the output unit a crucial part of our computing experience. 1. Accepting coded results. The output unit receives results from the computer, but here's the catch: these results are in coded form. They're like a secret language that the computer understands but might not make sense to us. 2. Conversion to readable form. Acting as a translator, the output unit converts these coded results into a readable form. It takes the computer's secret code and transforms it into something convenient and understandable for us. 3. Presenting converted results. Finally, the output unit presents these converted results to us. Whether it's on a monitor screen, a printed page, or a plotted chart, it showcases the outcome of our digital journey in a way we can appreciate. So, think of the output unit as the narrator, taking the coded tale written by the computer and turning it into a story we can read, see, or hold. Central Processing Unit, CPU. The CPU, often referred to as the brain of the computer, is a marvel of technology. It's like the conductor orchestrating the symphony of instructions and data within a computer system. The CPU is crafted as a single integrated circuit, IC, commonly known as a microprocessor. Slide. Anatomy of the CPU. The CPU is not just a single entity, it's a sophisticated system comprised of several integral components. Let's explore its anatomy. 1. Set of registers. Within the CPU, there's a set of registers, tiny, high-speed storage units that play a crucial role in storing and managing data. Think of them as the quick-access memory of the CPU. 2. Arithmetic Logic Unit, ALU, and Control Unit. The CPU houses the Arithmetic Logic Unit, ALU, responsible for performing mathematical and logical operations, and the Control Unit, which oversees the flow of data and instructions. Together, they form the dynamic duo that interprets and executes instructions in assembly language. Now, let's dive into the primary functions that make the CPU the powerhouse it is. Slide. Anatomy of the CPU. The CPU is not just a single entity, it's a sophisticated system comprised of several integral components. Let's explore its anatomy. 1. Set of registers. Within the CPU, there's a set of registers, tiny, high-speed storage units that play a crucial role in storing and managing data. Think of them as the quick-access memory of the CPU. 2. Arithmetic logic unit, ALU, and control unit. The CPU houses the arithmetic logic unit, ALU, responsible for performing mathematical and logical operations, and the control unit, which oversees the flow of data and instructions. Together, they form the dynamic duo that interprets and executes instructions in assembly language. Understanding the control unit, CU. The control unit is like the conductor of a symphony, coordinating the interactions between various components within a computer system. It's the silent force behind the seamless execution of program instructions and the smooth coordination of input and output devices. So, when we talk about the control unit, we are delving into the realm of coordination, communication, and control within a computer system. Now, let's uncover the specific functions that make the control unit a crucial component. Functions of the control unit. The control unit wears multiple hats, and here are its primary functions. 1. Coordinating with input and output devices. The control unit acts as a mediator, coordinating with input and output devices. It ensures that the communication between the computer and its peripherals is seamless and harmonious. 2. Directing program instructions. When it comes to executing stored program instructions, the control unit takes center stage. It communicates with the arithmetic logic unit, ALU, and registers, directing the computer to carry out the specified operations. 3. Organizing data and instructions. Beyond coordination, the control unit is an organizer. It manages the processing of data and instructions, ensuring that each component plays its designated role in the digital symphony. Core function of the control unit. At the heart of its operations, the control unit has a fundamental task: fetching and managing instructions. The basic sequence involves the control unit fetching instructions stored in the main memory, identifying the operations and devices involved, and generating control signals accordingly. It's like the scriptwriter, director, and stage manager rolled into one, ensuring each operation unfolds flawlessly. Understanding the memory unit. The memory unit plays a crucial role in the life of a computer. It's the storage space where programs and data find a temporary or permanent home. This unit comprises two essential components: primary memory, main memory, and secondary memory, auxiliary memory. When we discuss the memory unit, we are delving into the realm of storage and retrieval, where the computer's memory acts as a dynamic workspace. Let's unravel the specific functions that make the memory unit a vital part of every computer system. Functions of the memory unit. The memory unit serves as the digital librarian, managing the storage and retrieval of programs and data. Here are its primary functions. 1. Primary memory, main memory. This is the active workspace where the input data that needs processing is brought before the computer's CPU. It's like the working desk of a computer, where tasks are managed in real time. 2. Secondary memory, auxiliary memory. Beyond the immediate workspace, there's secondary memory. This is the digital archive, responsible for permanently storing data, programs, and output. It doesn't deal directly with the CPU but acts as a reliable storage space for long-term use. Significance of main memory. Main memory, or primary memory, is a quick-access storage where the action happens. When you load a program or open a file, it's brought into the main memory for swift access and processing. It's like having a desk where you lay out the tools you need for immediate tasks, efficient and fast. Role of secondary memory. Secondary memory, on the other hand, is the long-term storage solution for a computer system. It's like the library archive where books are stored for future reference. Secondary memory retains data and programs even when the computer is powered off. It's the go-to place for storing your digital archives, ensuring nothing is lost. Alright, tech enthusiasts, that brings us to the conclusion of our deep dive into computer architecture. We've journeyed through the intricate components that form the backbone of every computing device. Before we wrap up, let's recap the key takeaways. We started by unraveling the concept of computer architecture, the blueprint that defines the functional behavior of a computer system. From the first introduction of computer architecture, in 1970 by John von Neumann to the present day, where it's the foundation for all our digital experiences, it's been quite a journey. We explored the crucial roles played by the Central Processing Unit, CPU, the control unit orchestrating digital operations, and the memory unit acting as the digital vault for programs and data. These components work in harmony to bring our digital world to life. As we wind up, I encourage you to stay curious and keep exploring the ever-evolving landscape of technology. Whether you're preparing for exams like banking, SSC, railway, police, or any state-level exams in 2024, this foundation in computer architecture will serve you well. If you found this video helpful, don't forget to hit the like button and subscribe for more content. If you have questions or specific topics you'd like us to cover in future videos, drop them in the comments below. Your feedback is invaluable. Thank you for joining us on this tech journey. Until next time, happy exploring, stay tech savvy, and best of luck with your exams.